So so let's just formalize this a little bit. Find the average rate, which is the change in y over the change in x. Okay. It's the average rate of change with respect to body weight. Okay. With respect to is the one that goes in the denominator. Okay. So that's average rate of change of y with respect to well, that's pretty easy. So I'm gonna go detail than others, some real fast than others. But okay, so what's delta y? It's the difference in the two weights, the difference in the two amounts. Okay, it's 80 milligrams. Minus 50 milligrams. And change in body weight, difference in body weight is 270 pounds minus 180 pounds. That equals 30 milligrams over 90 pounds. Now this is pretty much whatever you're paying much attention, or if you hadn't had much sleep. And subtract 50 from 270, okay? Or something like that. Actually, you can't subtract pounds from milligrams. Technically, those aren't subtractable quantities. But they're usually now 30 over 90, everybody, almost everybody got 1/3 done. Okay, so or anything, you don't want to see that. Okay, so you have 1/3. That is milligrams per pound. Okay. We want to increase the amount by 1/3 of a milligram for every pound. Pounds multiplied by a third of a milligram per pound would be 60 milligrams. Okay. We're only supposed to give them 50. So we got to be careful that we don't think that this means we multiply this by the number of pounds. Now, I'll probably come back and make a little contrast between this situation and that situation. Okay. Put this information on a graph. Okay, and that's very simple. Weight in pounds. We would have 2 points on a graph. Okay. 180 pounds and 50 milligrams go together. So we find on the graph where 180 pounds is. And I say X equals 180. I've already said that this is in pounds. I don't have to write pounds again. This means 180 pounds. And fifty milligrams. Okay. Then we have 270 pounds. And now we have average rate by finding delta X and delta Y. Delta X equals 270 minus 180 equals 90. And delta Y equals 80 minus 50 equals 30. Does that make sense? So this is a graphical depiction of our information and the details of our calculation. Problems on the homework that you did for today, okay? And it would have been much to your benefit to do that, but you're going to have plenty of opportunity to draw pictures for things in the upcoming assignments. So we want to connect what you've already done, which is finding this file. Equals 30 over 90 equals 1/3. This line, right? The hypotenuse. Okay. And the difference in the amounts of medication. Okay, because I said it's an antibiotic. Okay. Make sense? So that this calculation of the slope gives us the average rate of change. Right there's the definition of average rate of change. You can put that in here. Toggles will the average rate of change is the basis for first semester calculus. Called the derivative, except it isn't the derivative until you shrink delta x and delta y down and let them approach zero. Okay. And it has a meaning. And that whole thing of shrinking things down and letting them approach zero. See the symbols, you have an idea to go with the symbols, okay? And the idea is kind of like this, just to give you a quick. This line doesn't go through the origin. Thing is supposed to behave as kind of like this. That's kind of like shifted square root function, isn't it? But it could be an upside down exponential. Could be a lot of different things. Okay. And I don't know what it would be. If this is an antibiotic you're measuring, that you're administering to a person. I don't know how close it is to linear. And I don't know how administered by medical people who might or might not away completely. Okay. For a hobby, they do multivariable calculus. Okay. Well, I know multivariable calculus probably as well as they do, but they're doctors. Okay. And they probably do it more easily than I do. Because some doctors are really, really smart at a lot of things. My wife is a nurse practitioner, or was till she retired. Got her license lapsed a couple of years later. And she worked with a doctor who was originally an engineer. A good guy. And he was a good doctor. Okay. So you have plenty of doctors and other medical professionals, nurses, nurse practitioners. You're pretty good at math, so outstanding at math. The first doctor in this area that my wife worked with had the highest score on the math exam in all of Ireland, where the education is much tougher than it is here. On the other hand, I've got a doctor who says, yeah, I'm just not a math guy. Okay. I mean, he's got through it and everything. It just doesn't click with me. Okay. So you have that whole variation. Now, the reason I talk about that you make a straight line out of a stupid thing. Okay. That makes sense. So we do the straight line approximation. So right there is a straight line approximation that works from 50 milligrams to 80 milligrams. Okay. The thing you're going to see situation in calculus, you take the point of this graph, and yeah, you've got a straight line that connects these, but you can do a straight line that connects two points that are closer to this. and closer and closer, and eventually you get a line that's pretty close to what we call the tangent line. It just kisses this graph at one point. Okay, and the way the function approaches that tangent line. And I could show you how that works with a quadratic function. You have the function notation, you have the algebra. You could do that right now. I'll probably show you at some point, but we're not going to digress any further on this idea today. But that's something that's worth storing more, especially if you have a calculus course, even an applied calculus course. And this could particular time, we've got this point on the graph. Now, what are we going to do? How are we going to maximize our profit? How are we going to do any number of things? Okay. So that's why this is important, and that's why I'm so glad everybody did well on it. Because I think you can understand at least what I'm talking about here. Okay, well, we go to this one. Say, what's the slope of the straight line? Okay. Okay, so we say, okay, here's the run. That's delta x, that equals 300 minus 200 equals 100. Here's the rise. Equals 180 minus 80 equals 100. So here's slope, which is the rise divided by over delta x. 100 over 100. Picture, if you're unfamiliar with this picture, could be easy to identify because I put a box around it. It's the only thing that got a box around it, right? Can you identify the slope here? You know, fundamental triangle. I label the run, I label the rise. You know, didn't rise equals delta y, but I can append that somewhere. We would identify the rise with delta y and the run with delta x. Okay. And then if we know slope is rise divided by run, that immediately tells us, once we've calculated these things, how to get this. Okay. Now, the one thing we don't do is we don't divide 80 by 200. Okay. That's not a rate of change. 80 divided by 200 is just we divide the change. Very happy about that. Okay, and you need to be happy about it too, because you're learning stuff. I didn't say anybody, I don't think, might have seen one case of just dividing one number by another. But I don't think I saw it. But still, it's a common mistake. Don't make it. Just caution. Does that make sense? Average rate is a change divided by, it's not y over x, it's a change in y divided by change in x. Okay. Sometimes y over x is important too, but it's not an average rate of change. It's not a rate of change in any sense except one very special sense. All right, well, very good. Very good. there's another thing that I did in the support course. That really Tuesday night, and then it's over falls Wednesday, it's still gonna be around on Thursday, okay? Assume, or at least take the precaution of covering this idea quickly. Right now. Talked to my brother last night at his birthday. He's got a cat that got sick. I mean, you go to a vet and the cat was gonna die. Okay. But they put it in antibiotics and it responded spectacularly. He was afraid it might cost 20 grand. And they were willing to spend that because they really love the cat. But let's talk about antibiotics and cats instead of people, okay? I will do slightly different. Also, I mean, there's a stray cat. Thought it was feral around the house. A couple of years, it was running, you know. Started letting me get closer and closer. And I wasn't trying to get close. I don't particularly like cats. Okay. You know, I don't hate them. I just find them irritating. But I understand that, you know, there are a lot of good things about cats too. Well, long story short, this cat turns out to be the tamest, best behaved cat you could imagine. We let it in the house, except we've got a dog with a very strong. Only 20 pounds. Yeah, 22, 23. He'd find a way. Very energetic, even though he's 12 years old. So, anyhow, long story short, cat got sick. And well, I'm gonna keep feeding him. I'm gonna keep petting him. Hopefully he's gonna live. That's all I'm doing. Me and my wife did too. We didn't spend $7,000. We spent a chunk of money. Okay. And I still think the cat's gonna die. Be difficult for my wife. Well, they find a shovel and bury it. Okay. Uh, and you know, I regret it because it's a really nice cat. Okay. In a cat hospital, between $1,000 and $2,000 a day. There are rates of change involved in all of that. What's the rate of change in my peace of mind with respect to the amount of money my wife would be willing to spend on a cat? Um, 6-pound cat needs how much is a 10 pound cat need? The milligrams per pound. Okay, and let's point out that this model here with people, remember, we said that wasn't a straight line model. That might be a curved model, and we're just approximating it between 2 points with a straight line. $50 milligrams divided by 80 pounds at 0.55 repeated, or yeah, 0.55. Wait, that'd be 50 over 90. It would be about 0.23. You divide 50 by 100 and you get this 270 pound person that gets 80 milligrams. Might have having to do these more complicated calculations. If I divide 280 by 270, if I divide 80 by 3, it's like 26. That's going to be than this one does. Metabolize, it makes this difference. Okay, so my point is that this person is getting a different amount per pound than this person is. Now, a direct proportionality y directly proportional to x is equivalent to, that's not an equal sign, it's a double arrow. It means exactly the same thing as y equals kx. Now, if we know that y equals kx, and if we know that y equals 14 milligrams when x equals 6 pounds, right? Okay. If y is 14 milligrams and x equals 6 pounds, then $14 milligrams is K times 6 pounds, and we can easily solve that for K. Actually, 2 1/3, that's close to 2.3. We say 2. If that extra 3 makes a difference. I'm not going to say them, but I'm thinking bad words here. No, it's okay. Something just popped up on my screen. Looked like Zoom might have crashed. You didn't. So I'll keep the bad words to myself. Shucks. Oh, let it slip out. Okay. Anyhow, here we go. there's, okay. We understand so far? I'm just asserting that direct proportionality means this. Okay? I'll draw a picture of it in a minute. It's 2 milligrams per pound times X. X is the weight of this cap. And we usually get 23 milligrams. Next cat we see needs this antibiotic, we weigh it. We don't have to do all this again. We just use the fact that we need 2.3 milligrams for every pound of body weight. And that's pretty accurately. A 10-pound cap, same amount of anesthetic you give a 6-pound cap because it might not be enough, right? Now, if it's amoxicillin, there's a lot of latitude. You give them both about the same amount. Or maybe you have, okay, 10 pounds, I gotta give them a little, okay? Get confused, that you don't want to risk any confusion at all when you're dealing with medications, right? So you say it. This fairly simple proportionality, the less likely I'll just screw something up. A picture of this. Y equals kx corresponds to a graph to the straight line through the origin. And through the origin. Okay. So now this really tells you how many milligrams you need for every pound. If we go back to the Where's the problem? The straight line through these points doesn't go through the origin. Now, don't worry. Determined that it doesn't go through the origin. Okay. Now, one of the assignments you have is going to be on proportionality. Proportionality is not always y equals kx. Frequent proportionalities are like y equals k times the square root of x, or k times x squared, or k divided by x, or even k divided by x squared, or even x cubed. Okay? Those correspond to the graphs you've learned to construct. Okay, now I'm not going to talk a whole lot more about straight lines, but you do have an assignment of proportionality that will be due before class a week from today. In case we miss next time, I want to go with that. Did we talk something about inverse functions last time in here? I reversed the column. I don't remember, and you don't remember whether you did it in here or in the support course. We do the support course a lot. Yeah, I've got plenty of time here, so let's. Has values you ought to be very familiar with because you learn how to construct them before you learn how to calculate them, right? You were able to construct them, then put these y values on the graph without doing it. With signs, so we spent a little time on that, but you know where these numbers come from. Okay. Looks like this. Does everybody see how you get the inverse table? If you have the table, what do? You just put these numbers in the X column, the Y numbers go in the X column, the X numbers in this table. But you should be able to read that paragraph too, right? Okay. So that's it. That's how you get a table for the inverse function. Now, if you want to do a graph, okay, you subdivide this rectangle. I'm going to make it a little higher. I'm not going to make it high enough. But, you know, we do our subdivisions. Put our red dot there. Do the make sure I get the right points, so I don't. Mislead anybody. So there's our graph of y equals x squared. Okay. Our graph of y versus x for the inverse function is gonna look like, I better go ahead and subdivide it. We have 4, -2. Here's y equals -2. So we're gonna have this point. Then we're gonna have a point here, point here, a point here, a point here. Wait a minute. Point here, and the graph is gonna look like this. Now you're gonna see pictures of this. You can draw this in your own graph. Okay, it's not too hard to figure out how to do that. So I knew you'd be able to catch it. Okay. So now the problem is it's two. I'm not going to say too much about it. We're going to choose this part of the curve, and that part corresponds to this part of the y equals x squared curve. Make it up. So that means I'm going to kind of ignore this part of the x squared. The function is 1-to-1. If I remove this branch, the function is 1-to-1. Every horizontal line goes through the thing at one point, exactly one point. There's exactly one x. I kind of cross out this part of this function. It's on a restricted domain. X has got to be greater than 0. So that y equals x squared, but only the part for x greater than or equal to 0. This part is the inverse function. Anybody recognize what that graph looks like? It kind of looks like an upside down exponential, but more properly, the graph that just kind of starts right here and goes like this is a square root function. Okay. Of the x squared function. It's a square root function. Okay. Now, Okay? Well, you go back to how you do composites. F of x equals x squared. So F of F inverse of x, you replace x by F inverse of x. And you replace this x by F inverse of x. Does it squares things. If it eats an F inverse of x, it spits out an F inverse of x square. Okay. Word. What do you get when you square the square root of x? You get x. Square root of 25 is 5. First relationship. And I'm not going to do this just because I'm trying to do a lot today because we might not be here next time. This is how you verify. And I do a lot of board washes for my next class. The sides of this board are used, but I still got that. Okay. Well, first of all, you let y equal f of x, right? So y equals 2x minus 3. That's your first step. To find the inverse function, what did we do with the tables? X became y and y became x, right? We swapped x and y. So we swap y equals. In other words, y is going to be the value. All we do is we solve for y. In this case, it's very easy. We add 3 equals 3, x equals 2y minus 3. We get x plus 3 equals 2y. 3 over 2. So f inverse of x should be x plus 3 over 2. Can we verify that this is this board needed? Okay. While I wash the board, I'm going to ask you to do this. We test whether these things are inverses. And to do that, we do f of f inverse of x. Well, you start there. Okay. And then we're going to do f inverse of f of x. And you get to start there. Okay. I'm going to move this over a little bit so I've got room. Give you a little more room to see it. Try to stay out of the way. Okay, so what's f of f inverse of x? Well, f of x is 2x minus 3. So this would be, things making me nervous, 2 times f inverse of x minus 3, which equals 2 times x plus 3 over 2 minus 3. Well, the 2's divide out. This leaves us x plus 3 minus 3, which is equal to x, which is exactly what the inverse function. Okay, gives you a value. And you put that into the original function, and it undoes what the inverse function did. It gives you back f of f inverse of x is, or sorry, f inverse of f of x. Here's your f in. Minus 3 plus 3 divided by 2. Well, minus 3 and plus 3 gives you 0, gives you 2x over 2, which is equal to x. Pretty simple, right? Okay, we've got time for another calculation. I'm sure that makes you happy. Yeah. This one. No. F of x equals 3 over x minus 7. recommend that you write out the reasoning of these steps so that you'll remember them. Instead of just doing them mindlessly, remember why we're doing them. Remember the logic, okay? Especially if you're going to go on into a whole lot more mathematics. It would be very beneficial for you to do that. So I'm going to write it out like I, y equals f of x equals 3 over x minus 7. So y equals 3 over x minus 7. We swap x and y. You remind yourself, first of all, that this means y equals f of x. We choose to let y equal f of x so that now we have a y and an x so that we can swap. Now we have it in the and we get x equals 3 over y minus 7. Now we solve for y. Y equals f. You have a denominator. Multiply both sides. On both sides. And I'll write that as x, y now because this almost looks like y is a function of x. And if we do that, y divides the y, leaving us with 3. Y times 7 is 7y. Now we've got xy equals 3 minus 7y. We want to solve for y, and we have y here and we have y here. What are we going to do about that? Well, we want all the y terms to be on one side. So we add 7y. And we get xy plus 7y equals 3. Now we're still saying, okay, xy plus 7y equals 3. Plus, it really loses all meaning. Okay, but what's this foolishness always has a meaning. Okay, that other thing is not very specific. It's useless, even though it sometimes feels good. Okay, makes sense? Okay, so anyhow, xy plus 7y equals 3. How do we do that? Well, we do a little trick. We factor out y. Something you should understand, but it might be pretty fuzzy. But you have to understand that the distributive law guarantees that this equals this, right? Because if you multiply y by x, you get xy, or yx, whichever way you want to do it. Then you multiply y by 7, you get 7y. So you can't dispute the fact that this is the same as this. By understanding the distributive law, you then understand a little something about factoring that maybe you didn't when you were just taught to do it by rote. If you were just taught to do it by rote, okay? That is usually the way it's taught. Okay, well then, what do? Divide both sides by x plus 7, because you want to get y. And unless I've done something really stupid, if I substitute this for x and do the algebra to simplify it, which is a little complicated. This, it would get maybe half a notch messier than this. Okay. And it could get a lot messier. Right now, the problems you'll have are mostly linear or this. So your next assignment is inverse functions. And then proportionality, and then some things about linear functions. Okay. So I hope to see you Thursday. If not, stay safe. And I'll most likely see you Tuesday, so the weather's going to be much better next week.